Uh, Hello everyone, very good evening to all of you. I hope I'm probably audible. Can you please confirm?
Yeah, Ashish, you are
Yes,
perfectly
sir.
audible.
Thank you. So let me introduce myself and then we'll start today's session. Uh, Myself, Ashish Pandey. I'm working as a senior AI consultant at McKinsey and Company. And as an AI consultant, I am helping industries to in technology adoptions uh, and also in data and AI auditing part. Today, in this session, we'll discuss about that artificial intelligence, data science, data analytics, and how to design the end-to-end solutions. The life cycle of any AI-based model will talk about it. So, artificial intelligence, data science, big data analytics, IoT, blockchains, all this digital technology or even RPA almost nowadays all industries are adopting and using it in different way is one of the most promising technologies nowadays. Almost uh, almost all manufacturing service industries or the product based industries are using this technology, digital technologies, and getting benefit in different way. If you see the most of industry, they are using the AI. I'll discuss about introductory part, but let's understand the particular applications wise how these industries are getting the benefit by adopting this digital technology. If you see the most of industry nowadays, they are using the data science and AI algorithms or AI techniques to enhance their current product. If you see the e-commerce companies like a Flipkart, Amazon, Netflix, they're using the AI to improve the search engine. Some industry they are using, like mostly like a banking and the finance sector, they are using data science and AI technology to make to enhance their customer experience or for more customer engagement or to optimize their internal process. All of you, can you please mute yourself? All of you, please mute yourself.
So, sir, some students are telling that they didn't getting your voice,
uh, I hope I'm properly audible, and all of you please mute yourself. It will be great. Yeah, thank you. Thank you to all of you. So nowadays, almost all industry like manufacturing or service industry, manufacturing industry, product industries, they're using this digital technologies in different way, or they're getting a benefit in different way by adopting these technologies. Like most of industry, they're using these technologies to enhance their current product or for more customer engagement, like mostly like banking, finance, or insurance sector. These industries are using it for enhance their customer experience or for more customer engagement. Some industry, there are lots of the startups that are coming with a new product, they're pursuing new business market through by designing a different solution. So let's understand that what is the AI and how it is, the difference between data science, data analytics, machine learning, deep learning, or big data analytics, all these technology. So artificial intelligence all about designing the intelligence software or the computer program which can make some decisions uh, similar way any intelligence someone can perform. So let's say in the day-to-day, our job profile, we take the loss of the business decision, and for that we use our human intelligence. So AI is all about designing the similar software which can take some which can be used to take take the similar decision or to perform the similar prediction. And the lots of industries are using it in different way by enhancing their current product, or they're using it to make a better decisions. Okay, so you see, like we can easily recognize the the different objects. Similar way, we can come with some AI based software which can also perform the similar task with a similar accuracy. Okay, and if you see the entire all over the architecture, and so there are the different way that we can design such kind of with intelligence software or the applications AI is all about. AI consists, there are the different tools and the technologies. Using that, we can design the intelligence software to make the, smart decisions, or smart decisions. And one of the very famous techniques is machine learning. So machine learning is collection of powerful AI algorithms which uses the historical data and learn the patterns from it, and then use that learning to make the decisions for the future inputs, or future, to handle the future questions, or handle the future queries. So machine learning consists, the powerful AI algorithms which uses historical data, or which uses data to learn it or to become intelligence. And during the learning is use some mathematical, with the help of some mathematical functions, it learn the particular patterns present to the data, and the base on the basis of the similar patterns, it make the prediction or handle the some future queries or the input. Similarly, a deep learning is again subset of machine learning. So deep learning algorithms also uses the historical data and use their mathematical techniques and they learn the patterns. So only the difference is deep learning algorithms are inspired from the human brain mechanisms or human learning process. So in the human brain, we have a network of natural neurons, and all the neurons, are responsible to process the different signals in the real time. And because of that, we'll able to, recognize the different objects, identify the different objects in the real times, or we'll able to make the decisions. So in the deep learnings, we design, some AI researchers, they come with some architecture which is inspired from the human brain mechanisms or human brain learning process, how the human brain process the different signals. And their extensive knowledge of deep learning algorithms. So in the deep learning, we basically study the different neural network architecture, and that can be used it to, to design the similar kind of the solution. So deep learning algorithms are very powerful and capable to learn any kind of the data, and we mostly use a deep learning algorithm when we deal with the unstructured data. Data is represent, the information. As we discussed, machine learning algorithm uses data for learning, and deep learning is again subset of the machine learning. So deep learning algorithms also require data, and algorithms are just a mathematical functions on the basis of the probability, on the basis of linear algebra, or some statistical techniques. And these algorithms help to learn the patterns present into the data sets. And these algorithms we consume into the different field, like in the field of computer visions, in the field of natural language processing, in the field of data science. Even we use these algorithm AI algorithms, or robotics, advanced signal processing, where we use this algorithm to design intelligence software or the applications. Okay, so as we discuss, artificial intelligence is all about, in the in the different way that we can define AI. So in very simple or layman language, you can say AI is all about designing the intelligence software, or kind of the intelligence computer program or the software which make some action or some decision in the similar way any intelligence human can perform. And such kind of the intelligence software, or we can design using different, so there are the different way that we can design such kind of the intelligence software. And one of the very famous technique is machine learning, because machine learning is collection of powerful AI algorithms which uses historical data to build such kind of the capability into the computer program or the software. There are some other techniques also in that we don't require huge amount of data, like some different genetic algorithms. But machine learning algorithms are very powerful, or widely it is used. And because of the digitalizations, data is not a big deal nowadays. Almost all organizations has a huge amount of data, and they're using the machine learning approach to design intelligent software or applications, AI based software or application. Okay, and as we discussed, there are different industries. Almost all, the manufacturing or product based industry or service industry, almost all industries are using, adopting these technologies and getting benefit in different way. If you see through the one particular survey, most of industry, they're using the AI by enhancing the current product. Some industries are using the AI by optimizing the internal process, or some industry they're using the AI to create the new product or for more customer engagement, or to for more customer engagement or enhance the customer experience. That is also very important. If you see, most of the banking, finance, or the service industry, they're using the chatbot applications to enhance their customer experience. So let's assume that there's a one industry, and to solve the customer query, the average time is a 5 minutes. Now the company want to automate the entire operation, but at the same time they want to improve the customer experience by reducing the average time to solve the customer query. So in that case, the company nowadays are using the AI-based chatbot applications. Okay. So now let's talk about the data science here. Okay. So before to the data science, let's discuss about the about the data. So data is represent the information. The first thing, your data may be in form of the structure or unstructured data. Structured data means where we have a table format of the data, in that we can perform some SQL query, or you know uh, CSV or Excel format of the data is, or database table is known as a particular structured data in very proper format, in that we have a data like a CSV or Excel format of data. Unstructured data means there's no any schema during the write, there's no any schema. And unstructured data, you can say like images, videos, or audio files. Such kind of data set are unstructured data. Both structured and unstructured data, both are represent the information in the real times. Or for any organizations data, it may be in the form of the structure also, or it could be in the form of the unstructures as well. And in the machine learning or AI algorithms, we basically learn the different algorithms which can learn any kind of such kind of the structure or unstructured data. Okay. So in the data science is all about, in the data science we basically learn the different techniques, or different techniques. With the help of it, we can different techniques that help to extract the insight from the particular historical or real-time data, and that information can be used to take some kind of the business decision. Let's understand through some example. Okay. So any industry, if you see the manufacturing, or if you see the manufacturing, service, product industry, even from the last 1 year, I'm doing some consulting, data and AI consulting for one of the global tire manufacturing company. And even for in any industry, if you see the the manufacturings or the product based industry or the service industry, top managers, CEO, or the the plant head, they use a different dashboard, real time dashboards, to monitor that, and they monitor the different KPIs. Okay. The KPI help to, the dashboards help to monitor the performance of their particular, the performance of their industry. So KPI, it could be total sales, total scrap, or total waste, total production. It could be any KPI. Okay. And if the graph is moving into the upward direction, means everything going good, right? Like in the stock markets, if the graph is going into the upward direction, so it's good. If the graph is moving into the downward direction, it means something going wrong, right? So basically in the all industry, even manufacturing, product, or the service industry, the top, the plant head, or the particular, the board of directors or the managers, okay, they use such kind of dashboard to monitor the different performance, different they monitor the different KPI. And for any manufacturing industry, the KPI could be total sales, or the total productions, total scrap, right? And so similarly for one of the banking industry, for them total, the KPI is a total sales, and as well as total number of the customer. Okay. Or total number of the query. If the number of the queries is very high, it means that the customers are not satisfied, the customers not satisfied. Or let's assume that if the graph is moving into the down directions of the total number of the customer, means that customers are exiting the particular bank, or they're leaving the bank, they're not happy with their services. It might be they're not happy with their services or their policy. So similarly, for one of the banking industry, like in the last 2 3 years, I have done the lots of the consulting project for the banking, finance, manufacturing industry. And why I have seen that, like almost all in all across all industry, the managers on the M3 level, or the plant head, or the particular uh, area managers, they use such kind of the dashboard, and interactive dashboard or real time dashboard, to monitor the different KPIs, and that help to monitor what is happening in the industry. It's give the visibility like what is happening in the industry. And such kind of the dashboard can be designed using a Power BI, a Tableau, or in the Python as well, we can design such kind of real-time dashboard. In the Python, we have a function like a Python dash, and with the help of it, we can design such kind of the real-time dashboard, which is the open source. But industry also use a Power BI, Tableau, QuickSight, okay, such kind of license-based tools to design an interactive dashboard, or the Grafana, we can be use it. Depend on the data and the op- uh, requirement, we can select these tools and design such kind of the interactive dashboard, and that help to monitor what is happening in the industry. Okay, let's say if something going wrong, so we want to analyze that, we want to know that why it has happened, which factor influencing such kind of a trend. So in that case, we perform the diagnostic analytics, and where we perform some operation on the historical data, and that help to perform some root cause. And where the data analysts and analytics, that particular part we say as a data analytics. In that, we use some statistical techniques, some data visualization approach to perform the root cause or to perform the diagnostic analytics. Let's say the loss of the customers or the banks are leaving, they're not happy, okay, they're leaving the particular account. So all the top managers, they want to know that what has happened in the past, why the customers are closing their account, which factor influencing such kind of a trend, they want to know that. So here, as a data analyst, we can ask the bank, okay, give us the historical, the information of the customer who left the bank, and also give us some information of the customer who did not left the bank, and then we can be use some data visualization or the statistical techniques to perform the root cause, and we can design some analytic report and share with the managers, and managers can use those information to get the insight, to get the answers of all the business question. And where we use a particular data analytics or data analysis, we use it using some data visualization or the statistical techniques that help to perform the root cause. And that's something very very important across all industry, performing the root cause. It's something of very, because root cause help you, to identify the potential reason for that, impact. And then accordingly we can we discuss with the leaders or the business team to perform the next level of action. So here the data analysis or analytics we are using to perform the root cause, or we are using some statistical or data visualization approach. Now the next part is, okay, we can pass the report to the policy maker or the managers, and they can design some new policy. But again, to design the new policy or to get the results very on time is not possible. It takes some time to get the particular results, right? Let's assume that today you are designing some new policy which help to improve these particular things. So but it will take time to get the result. It's not possible now today if I'll implement some policy we will get some good result onwards. It will take some time. But meanwhile, we don't want that company will lose more and more customer, or company will go, graph will move into the downward direction. So we can use some, we can design some predictive model in this case, which will help industry to predict which customer will left bank in the future. And accordingly, that information, let's assume that in the real time the bank can the bank can check it, which customer is more likely to left bank after the 2 days, after the 3 days, or in the future, and why, and as well as why. So that will help the particular bank to, then accordingly the bank can take some actions and resolve the customer query, so that customer will not left bank in the future. So here we can use a data science where we use a machine learning algorithm to design the predictive model. Then the next step, again the bank may face similar issue in the future. So where we perform the prescriptive analytics, and again we use some advanced deep learning algorithm to design the recommendation system, which takes the input from the various factors, like from the governments, from the local government, or the particular banks, or from the various, it take the input from the various places, and give some kind of the suggestion to the all the plant head or the policy maker, and they can take those particular input while making the new policies. So that will help the particular bank or the managers to overcome from such kind of the problem, or the bank will not face similar issue in the future. So in this way we can use this four level of analytics, starting from the descriptive analytics using a dashboard. Using the statistic and data visualization approach, we can perform the diagnostic analytics, and that help to perform the root cause. Using the machine learning algorithms, we can design the predictive model, and that will help to that will help to the particular save the loss of the particular uh, uh, improve the particular productions, or decrease the scrap, or that will help in this case it will be help to the particular reducing the churning rate. Then the recommendation system, again where we use a deep learning algorithm, that will help to perform the prescriptive analytics, and that will help, again this will help the organizations to overcome from this such kind of the problems. And in this way we can perform this level of the analytics, four level of the analytics. Let me share with you one real time case study. As I mentioned, like from the last 1 year, I'm designing the solution for one of the global tire manufacturing company. And in the tire manufacturing company, one of the big thing is a scrap. And because obviously there's a production and there will be the scrap as well on the daily basis. Now the company want to reduce the particular scrap, but on the very beginning level, there's no any visibility. If something getting scrap, what is the potential origin, what is the potential reason behind it? So what we have done is we designed the tableau based dashboard, and that help that helps to the particular uh, all the managers or the shift manager to identify if something is getting scrapped, what is the potential reason behind it. This is something caused by the man, machine, material, or the process. Or if the any particular tire is getting scrapped, so it is the particular curing related scrap, or the building related scrap, or the process related scrap, and how we can improve it also using the skill matrix. And that solution help the organizations to save around to the 10 cr annually. Okay. So similar in the tire manufacturing process, there is a building area, there's a press. Curing press give the the shape the particular the tires, and there's an inspection area the where we have the uniformity, visual inspection. So we also implemented lots of the machine learning algorithm on the machine, and that helped to we design the different predictive model and deploy on the machine, and that helped to reduce the scrap. Okay. uh, or to identify the particular reasons behind it. So in this entire course we'll discuss about that. We first we will understand the particular, we'll learn the particular different techniques, different algorithm, how to use the statistic, how to use a data visualization approach to perform the root cause, how to understand the business problem, and design the architecture, or design the strategy, and how to follow those strategy to design end-to-end solution. Okay. So as we discussed so far, artificial intelligence is a artificial intelligence is a collection of algorithms, and which can be used to design different intelligence software applications which can perform similar some tasks in this which can perform some tasks similar way in intelligence human perform it. And we consume these algorithm in the different field, or in the field of data science, in the field of computer visions. So in the computer visions, like we can easily we humans are intelligence, we have the eyes, and with the help of the eyes we can easily recognize the different objects in the real world. We want to build this capability into our software, so the software can recognize the different images or see the world with the help of the camera. So using the computer visions, where we use a deep learning algorithms, and we can build such kind of the capability into our software. Similar way, we want that our devices should be very smart and can talk with, understand the particular human language, because we use we use a natural language for the communication, or to share the knowledge or the information or data, correct? We want to build such kind of capability into our software, so that we can easily interact with the software, and the software can understand our language, so that it will become very easy to perform the root cause, or to solve the problem. And such kind of the capability we can build it inside of the software using the natural language processing, where we use a deep learning algorithm. In the field of the data science, as we mentioned, that to perform the predictive or the prescriptive analytics, we can use the machine learning or AI algorithm. Advanced signal processing or the robotics, where we can use such machine learning or deep learning algorithm. Okay. In the field of data science, we mostly work with the structured data. Like in the NLP or the computer vision signal processing, we deal with unstructured data, and that's why we widely use a deep learning algorithm. In the data science, we deal with the structured data, and where we use a machine learning algorithm. Okay. Now let's talk about that how to implement it. Okay, fine. So let's assume that we have some business problem. Okay, and we want to design some solution. Whenever you have a business problem, now the first step is design the entire strategy, or where senior data scientists will help, or give the particular the entire plan or the strategy. We spend the lots of time only in the discussion with the leaders or the clients to understand the exact business problem, and then accordingly we design the strategy. Okay, or we say as a particular implementations level, IL1, IL2, IL3, IL4, and IL5. On the IL1, we first understand what is the customer requirement, what is the business problem. We calculate their value, how much, let's assume that how much your solution value it will be add. Okay, how much value your solutions will add to the organization. It is very important to calculate in the starting. Then after, once all the leaders are agree with your solution, we say that we are done with the IL1. Then we start with the IL2, where we build the particular teams and we design the strategy that we can use this strategy, these tools to implement the solution. Then on the IL3, we design the solution, we design the POC, proof of concepts. So here, to design the proof of concept for the data science, machine learning, or AI algorithms, we widely use such kind of the tools. And on the very high level, there are three kind of the tools we use it, or there are kind of the approach. Yeah, there are type of the approach that we can design such kind of a predictive model. One is using the programming language or scripting, where we can use such kind of the open source programming language, or we can use a different programming language like a Python programming, Python, R programming, Julia, or the MATLAB. Okay, we can use such kind of the programming language, such we deal with a database like a SQL server or MySQL. Okay, no SQL, so depend on the particular data we use this programming language like a Python programming or R or MATLAB, or even Excel also nowadays widely we use in the industry, but again Excel has some other limitations. Okay, so first part is scripting, where we can use such programming language and we write a code and work with the data, design the machine algorithms, and implement end-to-end solution. Second part is no code or the less code, where we use a designer tool. In that, you don't need to write a single loss of the code. We have some pre-configured node. We just drag and drop and add it use in the canvas, and we can easily design the solutions and deploy it. And the last approach is auto ML. In that, you just need to load your data set, select it whether type of problem, whether it is a regression, classification, forecasting, anomaly deductions, or recommendation system. Okay, or the dimensionality reduction. You need to just specify the type of problem, load the data set, and just you need to do some kind of the few more clicks, and it will automatic select the best algorithm for the given data set and deploy on the particular production environment. So the first part is scripting, where we can use such kind of the programming language, and from the very scratch we can load data set, we can connect with the database, or if you have a data into the SQL, Parquet, or CSV, we load it. We can perform some statistic, some visualization part, feature selection, feature engineering, machine learning algorithms, deployment part. All those things we do using a programming only. Okay, and we widely use this particular part in the industry, because whenever you want, if you want to design some custom solution, you have to do the coding. Second part is designer, where we don't need to write a lot of code. We have some pre-configured node, we just select, drag and drop in the canvas and connect it, and we can easily design solution. And the last option is auto ML or auto AI. In that, We just need to load the data set and specify the type of problem, and we can easily deploy onto the production environment, design the solutions and the deploy to the production environment. Okay. But in the industry, we widely use a Python and Python and the Python libraries to implement the data science, or to define the AI algorithms, or to design end-to-end solutions. Because Python is a multi-purpose programming language, you can use a Python for networking, automation, embedded system, AI algorithms, or for software automation, software designing. You can use the Python programming, or web applications, UI. We almost all, kind of the applications we can design using the Python. It is widely used in the industry. And Python has some, wonderful libraries, and using that we can easily call the different APIs or the functions, and we can load data set. We can perform data manipulations, data visualizations, data engineering, or we can feature selection, machine learning implementation part, deployment part. All those things we can easily do, like a pandas, matplotlib, seaborn, tensorflow, keras, okay, and scikit-learn, joblib, flask. All these libraries are very popular, and we can use their functions to deal with a different data set, perform some kind of basic level of high level of the analysis and data engineering, feature selection. All those things we can easily do that. Similarly, R programming also widely it is used, but it's up to you. Most of in the, in professor, they, or in the research, we widely use a Python, sorry, we use a MATLAB. And mostly like IT industry, they prefer the Python. They use a Python and R programming to design the end-to-end applications, or implement the data science machine learning algorithms. I hope it is fine for all of you. Any questions so far? Yeah. Any questions you have? Okay. All right, so let's continue. And we'll discuss about, as we discuss data driven solution, we can use a data science or machine learning algorithms, or to design data driven solution, or we can perform this four level of the analytics, starting from the descriptive and diagnostic, predictive and prescriptive analytics part. So descriptive analytics help to monitor what is happening, diagnostic to perform the root cause, why it has happened, predictive what will happen, prescriptive how to overcome from this problem. And where we use statistics, data visualization, machine learning or deep learning algorithms to perform this four level of analytics. Okay, so now let's discuss about about the machine learning. And because as we mentioned, in the field of data science, we use machine learning algorithm to design different solution. So let's discuss about it. Okay. The first, let's discuss about the machine learning. As we discussed, the machine learning is a collection of the powerful AI algorithms which uses data. Okay, it's collection of the powerful algorithms which uses data for the learning, and during the training, it's learn. It's uses their mathematical functions to learn the patterns present in the data set. Okay, and based on the learning process, we can categorize all the machine learning, all the algorithms into the three different sections: supervised, unsupervised, and the reinforcement learning. Where supervised machine learning algorithms uses label data. Label data means information with actual tag known as a particular label, and information without tag known as unlabeled data. So supervised machine learning algorithms, it's uses label data to learn the patterns Okay, and we can use a supervised machine learning algorithm to solve regression and the classification problem, where regression is the task of predicting continuous value and classification is the task of predicting categorical outcome. So if you see, the first we discuss the idea of the machine learning. Here we discuss the idea of the machine learning. Machine learning is collection of powerful AI algorithms which uses data to learn pattern and which uses data to for the learning, and during the training it's it's uses the mathematical function or algorithms to learn patterns present to the data, and on the basis of it is handle the future queries or the questions. And based on the particular learning approach, we categorize all these algorithm into the three different sections: supervised, unsupervised, and the reinforcement learning. Where supervised machine learning algorithms uses label data for the training or for learning. Label data means information with actual tag, non as a label. Okay. And unsupervised machine learning algorithms capable to learn the pattern from unlabeled data. Information without tag, known as a unlabeled data. So let's assume that you have in a folder and you have a multiple images of your friends or your colleague, and you don't have the but name of the image is very random. It's not represent the information present into your image. So we say we just have the information, but we don't have the any idea about, because it's the name is very random. It's not represent the actual information present into the images. So we say it is unlabeled data. Okay, we can say as an unlabeled data. Then we have a reinforcement learning algorithm, and we reinforcement learning approach or learning algorithm, you can say. So when it is not possible to collect all the pattern in form of the historical data, and okay, and when your particular learning agent supposed to perform some activity in some environment, let's you can just assume that the environment of the particular the video game, okay, where the agent performs some activity in the particular a gaming environment, or self-driving car, for them the environment is a particular all the particular the roads. And when it is not possible to train your models from all, even it is not possible to collect the particular all the patterns in form of the data of the particular rules of the traffic rules and the all the activity in the form of the historical data to train the particular car, to design the self-driving applications, self-driving car applications. So in such cases, we use a reinforcement learning where your agent means your software, use some sensors and or use some techniques and collect some information from the environment, and then again perform some activity or perform some actions on the environment. And environments give the particular feedback in form of as a rewards. And we program our agent in such way that the goal of we program it in such way that their goal will be objective is to get the more and more rewards from the environment, and environment will give the rewards only when the agent will perform the right action. So this approach, these things will help to learn the particular or to learn the particular things from the environment, or to become to perform the right actions. So mostly we use in the self-driving car or in the gaming world we use a reinforcement learning approach. So again, supervised machine learning algorithms can be used to solve two kind of problem. One is regression and second is a classification, where regression is the task of predicting continuous value. And let's assume that you want to design some model which can predict the valuation of the property based on some set of the features. So here we want some model which will be predict the continuous value. So we say as a regression problem. We want some models. So classification is the task of predicting categorical outcome. Let's assume that we want some model which can classify that whether person has a diabetes or not based on some some set of the features, or the particular customer will left bank or not based on some set of the information. Time series forecasting, for that also we require label data, and the forecasting is all about where the predictions will be on the basis of the past value, not a based on the feature, the prediction on the basis of the past value. Then again, unsupervised machine learning algorithms can be used to capable to learn the pattern from unlabeled data and information without tag, known as unlabeled data. And one of the application is a clustering. So clustering is all about the grouping of data point on the basis of the similarity. Anomaly reductions is all about designing the model which can detect the anomalous event in the real time or suspicious activity in the real time. Dimensionality reduction is designing the such AI-based model which can be used to compress information. Recommendation system is is kind of the applications that can, where we use AI algorithm to design the recommendation solutions, like a product recommendations engine which can give suggest some recommendations, like Netflix use a recommendations engine to recommend the different movies to their customer or the clients. So the first part is, in the real time, whenever we design the solution, first understand the client requirement, and then we categorize it, whether it is a regression problem, classification problem, or it is a forecasting problem, or it is a clustering problem, or it is an anomaly reduction problem, or it is a dimensionality reduction problem, or it's a recommendation. We want to design some recommendation engine, and accordingly we select, again we collect the data and we select algorithms, and we process all the particular steps to design the final applications of the solution. But the very important point is understand the business problem and then classify it accordingly. This problem can be solved using the regression algorithm, or the classification is a class, or it can be solved using the forecasting algorithms, or it can be solved using the clustering algorithm, or it can be solved using some model which can detect the anomalous activity or suspicious activity, or it is a problem where we want to compress the information, or it is a problem where we the client is looking for some recommendation engine. So it's very important to identify problems, and then accordingly we can take it forward and design the strategy and use right approach to build end-to-end solution. I hope this part is fine for all of you. So in the Python, we use a pandas. We can use a pandas to import, data set from, if you have a data into the form of the CSV, or if you have data into the Parquet or Excel or JSON or XML, we can easily import it, and then we can use a pandas functions to perform the various analysis, to perform the data cleaning, to perform the data transformations, and we can perform all the operations over there. And even if you have a data into the SQL Server or MySQL or the NoSQL like a MongoDB, any databases, so we can connect it and we can import data over. We can import data. Then we can use the particular, the data cleaning operations. We can perform the particular, data transformations, data pre-processing using the scikit-learn algorithm, scikit-learn library of the Python. And we can in the scikit-learn is widely used in industry. Whenever you want to implement the machine learning algorithm or data pre-processing, we use the scikit-learn, and we can directly import some ready-made algorithms, and we can perform all the operations over there. Then we can start the training and build the model, and we check the performance. If the performance is good on the testing data, so we say that model has learned all the patterns, typical patterns present to the data, and we can use it for the deployment purpose. But the performance on the testing sample is not good, so we perform some tuning. We tune the particular data, we tune some of the hyperparameter, and we try to improve the performance. And once we have a good model, we again we can we ex, you know we export the train model, and we can deploy it to any cloud environment like AWS, Azure, and perform testing in the real time. Okay, so I hope it is fine for all of you. Any questions so far? So this is the entire flow chart. As you can see, we start with the understanding of the business problem, where we identify, what is the end objective, what is the client requirement, and once we are good with this part, we work on the particular data. It's very important to understand the data, all the variables present to the data sets. Okay, so let's assume that in your data, if you have a 10 and 15 variables, so it's very important to relate and have a good understanding on the all these individual variable and how it is related with your business problem. Okay, and for that we also we take the help from the particular SME or from the client as well, to understand the data or to understand the business problem. And once we are good with this particular part, we go for the data preparation. So in the real times, your data, maybe in your data there's a loss of the noisy value, unwanted value are present. Maybe some of the feature is not important, some of the variable is not relevant, or it may be your data in the form of the text or the different format, so we use a different encoding approach. Okay, and we perform the data cleaning, data transformations, okay, or encoding, or prepare the data for the training purpose or for the modeling purpose. Then on the basis of business problems, we select the machine learning algorithms or deep learning algorithms, okay, or we design some custom algorithm and start use the training data and train the model. During the modeling, algorithms, during the modeling, software use their algorithms or mathematical function which help to learn the patterns present into the data. And after the learning, we say we have a model, and that models can be, we then again we perform the testing on that particular trained model using the test sample and use different metrics to check the performance, like accuracy, recall, FNS score, or R square score, mean absolute error, or root mean square error, to different metrics to check performance of the trained model. And if the performance is good, so we say that model has learned all typical patterns present into the training data, and now we can export the trained model and deploy it to the production environment. And then we use a different, we monitor the performance, and because, and again we build the CI/CD pipeline as well, continuous integration and continuous deployment using the MLOps or the DevOps part. Because let's assume that today your model performance is 80%, but it's not compulsory. Over period of the time, the model performance will be decreased, and maybe in the future, as we have some more and more data, there may be some, might be, there's a possibility that in the data there's some new pattern, and we want our algorithm to learn those, to also learn those particular patterns from the new data set. So we build end-to-end solution, and we quarterly or quarterly, or based on the particular applications, we design such kind of, pipeline. So we train the existing model, and so that model can maintain that particular level of the accuracy or the performance. Okay. So now, in the next section, we'll discuss about in detail. So today is just an introductory session. We just discussed the high level overview. We'll discuss in detail from the next lecture, and we'll spend some time to understand all these machine learning algorithms, and again, the supervised, unsupervised, okay, and how these techniques, learning approach work, and as well as a different supervised regression algorithm like a linear regression, polynomial regressions, descent tree regression, neural network regression, different classification algorithms like a logistic regression, descent tree classification, or support vector machine, and different forecasting like ARIMA, AR, MA, clustering like k-means, hierarchical clustering, TB scan, dimensional reduction, PCA, or SVD, anomaly detection, single class SVM, where we can be used it, and one class SVM. Then again, matrix factorization for the recommendation system, and so there are the different algorithms. So we'll discuss all these algorithms in detail. We'll understand their mathematical techniques and how it can be, use it and implemented, and then how to deploy the model using a Docker or Flask on the production environment and perform testing in the real time. Yeah. So I hope this part is fine for all of you. Any questions so far? Let me know. Now we are open for Q&A session. So if you have any questions, all of you, please let me know. So we'll discuss from the next lecture, we'll discuss this particular part in detail, and we'll start with the basics of the Python, and we'll discuss in detail like how we can use, how to implement all, design the end-to-end solution using the Python and the different libraries. Okay.
Yeah, all right, Ashish. Thank you for joining today. And thank you, participants. I mean, thank you, students, to joining today. Actually, some of the students might have some problems to join actually because of limitation of this account. And we will be sharing the new links to all of them to join from Monday. And you will be also getting the recording of this video so you can share with your friends, those who haven't joined the sessions. All right, thank you very much. Have a good day.
Thank you, everyone. Thank you to all of you.